So I have a set of slides here that will help you with your assignment. This is assignment 4, where we're going to ask you to use a lump parameter model, and that's going to be the Tracer LPM model from the United States Geological Survey, to understand the age of the groundwater at Rottnest Island. And probably you haven't been to Rottnest Island, which is an idyllic carbonate island off the coast of Western Australia. So to help you run the model for a groundwater system that you don't know, I've got a set of slides here which mostly focus on the hydrogeology and geology of Rottnest Island. And this will allow you to build a conceptual model, a conceptual framework, in which you can then apply a lump parameter model for the assignment and do it effectively and efficiently. So most of the slides here are photos, and they're going to help explain to you something about the geology and the hydrogeology of Rottnest Island. Here goes. This is what many tourists go to Rottnest Island for. It's the quokka. But that's not why I'm taking you on a virtual tour of Rottnest Island. I'm taking you on this tour of Rottnest Island so that you can achieve the first of these 4 steps to model groundwater flow. And the first step, and this has been covered previously again by Martin in lecture 5, is that you need to have a conceptualization, a conceptual model of the system that you're going to apply the groundwater model to, because if you get the conceptual model wrong, then the groundwater model will be wrong. So let's start with a map. And in the top left-hand corner, there's a map of Australia, and Perth is labelled in Western Australia. And there's an inset there which shows the size of Rottnest Island, which is just off the coast of Western Australia. And the main map is just the central part of the island, and you can see there's only a few kilometres long. There's a schematic on the bottom half of the figure which shows that the geology is limestone, something called Tamala limestone. I'll explain that in a minute. And it shows that there is a freshwater lens situated in the centre of the island, and beneath that and to either side, because it's a carbonate island, is salt water. So the concern for Rottnest Island is that there's a very small and limited amount of fresh water in this lens in the middle of the island. And if this is over-abstracted for drinking water supply, that would allow this salty water to be drawn in and contaminate the drinking water supply. And that's why there's so many boreholes. So you can see on the main figure, black labelled boreholes. There's black bores, which are the production wells. They're used for drinking water supply, and surrounding those on the outside are the red bores, which are monitoring wells. And these were put into position to see if they could detect this ingress of salty water. And you can get some idea of how long this problem has been going on for. The numbers on the bores reflect the number of the bore that year and the year it was put in. So bore number 25/90 is the 25th bore that was installed in 1990. And so you can see that the monitoring bores were largely put in place in the 1990s, when there was the first concerns that the water supply might be deplenished. Now, Rottnest Island is one of Australia's top tourist venues. So there are many thousands of visitors every single year. And on top of that, it's in a region of the country which has undergone long-term drought for many decades. And the concern of the Rottnest Island Authority was that the fresh water was being depleted, and they wanted to understand why that was the case. Was it because of over-abstraction or human use, or was it because of the drought? And part of that study was to use water isotopes as tracers to try and get an understanding of how old the freshwater is in that freshwater lens. That would give us some understanding of how sustainable its use would be. So this is a picture of a coastal section of the Tamala limestone, and it's made up of dunes that have only recently been fossilised. So you can see sand dune-like structures on the far side of this bay, and also visible in the foreground. And the Tamala limestone has been formed over the last tens or hundreds of thousands of years. So it's a very, very young rock. It's of Quaternary age, And because it's so young, it will retain its primary porosity and it will be only poorly castified relative to other types of carbonate. And here's a close-up of the bedding again. So you can see in the rocks, you can see these structures, and you can imagine this is how a modern day sand dune sequence would look like on a coast anywhere in the world. And just here, it's been fossilized, turned into rock, been lithified, but only in the last 100,000 years. So this is a rock type that's called an aeolianite because it's made from wind-blown material. So it's a carbonate and it's an aeolianitic carbonate. And this rock feature is found widely around the coast of Australia, all the way along the coast of Western Australia, through a lot of Southern Australia, the New South Wales coast, all the way up to Lord Howe Island, and now even out on Norfolk Island you find parts of this system. So it's quite a widespread feature, and in many cases it's used as an aquifer for drinking water supply, for agriculture. So it's an important resource. So the rock types have been studied, and if you want to look into more detail on this, this is a paper that came out about 6 years ago, working out the chronology of this Quaternary age. So the Quaternary is the last 1.6 million years of Earth history, coastal, aeolianite, so wind-blown dunes around Australia. This is focused on southwestern Australia and includes some data from Watness. And this is one of the figures from the paper. You don't need to know the details at all. It's just to show some sections of this limestone across different sites in southwestern Australia. And you can see it's widely just dune features, maybe several stacked on top of one another. Occasionally you might find something called a paleosol, a fossil soil, where there was time for the soil to form between the dunes. It often has these solution pipes, which are probably where tree roots have gone down through the limestone in the past, and there's been enhanced solution and castification. And you can see a whole bunch of ages in Ka, which is thousands of years, and you can see that these ages of the limestone formation place this at various times in around about the last 400,000 years. This is a very young rock type. And here's another section for you. So this is Fremantle, so just on the mainland across from Watness Island, and this is an amphitheatre in a quarry. So it's disused quarry. They've turned it into a music and theatre venue. And the walls, you can see really nice features. You can see the dune bedding features there, but you can also see the very light yellow these solution tubes, areas where there's been castification. And you can imagine where, if this was in the saturated zone, the phreatic, there are many voids here that could allow preferential flow of water. And you can also see here that there'll be water flow through the matrix, through the pores, but there's also bedding planes and areas which are more fractured, which will allow the faster flow of water through them. So it's definitely a karst limestone system. There's another picture from the coastline. This is again from the mainland and not from Watness, showing some castification, some caves, some conduits that have been exposed. This is on the coast, so the cliff has collapsed. You can see extensive conduit formation near the surface, just below the soil, and then these larger cave features. And then you can also see an unconformity between the dunes, this horizontal bedding plane feature, which again has been solutionally widened and has formed an area where there's been preferential water flow in the past. So this is definitely a karstified carbonate system, and one that would be very difficult to model in terms of all these various processes going on, and would be ideally suited to a lump parameter model, which can then subsume all of those into a simple lumped parameter method.